Okay, Professor Jim Schultz here for my Finance 680 students. As promised, I wanted to go ahead and do at least one problem from your Chapter 7 material, which is bond valuation. And looking over the problems and given what we were able to go through in class, I wanted to go ahead and do number 10 here from the previous exam. I think that this is a problem that's very different from any of the ones that you've practiced, and I think that this will be a good one for us to go over here in this video. Okay, so you read through the problem and you see that this bond has a unique payment structure. It's going to pay you $400 every 6 months for 3 years, then nothing, then $750 every 6 months for the final 2 years, and it has a face value of $5,000. What would you be willing to pay for this bond today? All right. In my opinion, and this is not the only way that you solve this problem, but in my opinion, this is the easiest way to see what's happening. You need to break this thing down into 3 separate timelines for basically the 3 separate segments that are listed in the problem. The first 3 years, where you're getting $400 every 6 months, you see right here. That middle period where you're not getting anything, and then the final 2 years where you get $750. Because if you do this, what you can see now is what do you basically have on your hands? You have 3 different annuities, right? So all you need to do is handle them separately and then add them together at the end, right? It really is that simple. So that's why I love setting it up this way, because it really makes it extremely clear what you need to do to solve this problem. All right, so let's start with this first $400 payment stream that occurs for 3 years or 6-month periods. All right, so basically you want to bring everything back to the present value. So at this point in time, so all I'm going to do is I'm going to find the present value of this annuity. So I'm going to set this guy up right here. This is your classic annuity setup, right? Future value of 0. I, payment, and N all have to be on semi-annual frequencies. That's why you see I divided by 2, and you see N being 3 times 2. And then you've got your $400 payment, so you get this present value. It looks like 2090.05. All right. Now, this middle component, you're literally not going to do anything with this because you're not getting anything. There are no payments that occur here, right? So, we could find the present value of this, but it's just going to be 0 because nothing happens. So we can skip right down to this annuity. Now, in my opinion, if you make it this far in the problem, that's terrific. But what's going to happen next is the real linchpin of what's going on here. You need to really have a firm understanding of when things are occurring in order to solve this problem correctly. All right? So, okay, you need to find the present value of this annuity. However, you need to remember, you need the present value back up here. Right? So you need the true present value in the sense that present value meaning today. All right? So, but let's look at this annuity. The first payment is in period 17, right? You get $750 4 times. So if I was going to find the present value of this annuity right here, how would I set that up? Well, it'd be pretty easy, right? You're looking for the present value. The future value is 0. Your I is going to be semi-annually. Your payment is $750, and it happens 4 times, right? All right, that's easy to do. You get 271602. But here's the key, and you see how I have written it here. This number that you found doesn't belong here yet, right? Because the annuity didn't start until period 17. So when you find its present value this way, that number that you find, this number that you found, if you had to put that on the timeline, it would go right here. It would go at period number 16. Okay? And if you're having a hard time seeing that, just think in your mind, right? Even scratch down on a piece of paper. Scratch down in front of you right now a 3-year annuity where you got $100 a year for 3 years. Literally, put the timeline. If I could draw it with my software, I would, but I really can't. I want you to draw a timeline right now that says 0, 1, 2, 3. And on the tick marks that say 1, 2, 3, put $100 at each tick mark. And here's my question to you. If you were going to find the present value of that annuity, once you found that number, where would it go on the timeline? It would go at 0, right? In other words, the present value of that annuity would be 1 period before the first payment begins, right? So you have to apply the same thing here. It just looks a little different because it happens in the future, right? So the present value of this annuity belongs 1 tick mark before the first payment occurs. So in this instance, that's going to be period number 16, right? So then what you need to do is you need to take this lump sum And you've got to bring it back to the true present value, just like I was saying when we begun this part of the problem, right? So the future value is 271602. Your I, it still needs to be semi-annual because everything is happening in semi-annual periods. There is no payment because you've already accounted for these payments, and you've got to bring this thing back 16 periods. And I don't know what that random 3 is there. That's probably a scribble. That's not 16.3, that's just 16. And doing that gives you the true present value of this annuity all the way back to today, or time equals 0. So that's 1427.98. And then all you need to do to find the present value of this guy is add up this guy, and then obviously you've got that face value that's lingering out there, right? Which is pretty straightforward. It's just a $5,000 payment that happens at the end, right? It's going to happen at this point in time. I didn't put it on the timeline because I wanted to handle it separately, right? But this should be pretty clear, I would think, to most people. So then you'll find that present value as well, and then you add up this number, and this number, and you get 57, 56, 52. So this is how you solve number 2 from the previous exam. A very good problem to practice heading into the midterm.